little bit about who I am. I've been a network engineer for over 30 years. What that means is I started with coax, ArcNet, Novell NetWare back in the days when you'd flop, here we go, you'd swap the floppies to compile the operating systems. One of my frustrations all along my career has been that a lot of network monitoring platforms really haven't advanced to the next level. What they all seem to be is, here, you can go out and ping some things, and you can set up your MIBs, set up OIDs, and go out and choose what to go collect from devices. Once you get that information collected, it's up to you to interpret what that information means. And I figured nobody seems to be moving to that next step. And I got frustrated about 10 years ago and figured, okay, this day and age needs to come to an end. There needs to be a new way of looking at networks. If you think about it, all of your network equipment has a wealth of information trapped up inside of those devices. What if that information could be automatically queried, intelligently analyzed, and you given plain English answers of saying, hey, did you realize you have a cabling fault on this port over here? Do you realize you have a VLAN tagging error on this trunk port over here? Do you realize that you have a missing default route on this router? If all that information could be analyzed and you told the plain English answers of when, where, and why you had packet loss, latency, jitter, any sort of problem, you could proactively go through and fix the problems. So instead of running a network full of mystery and unknown, you're able to run a network that's perfectly operating because you know what the equipment knows. So that's been our desire from day one. What I'm going to do is go through what our product is able to do for NetOps. We also have a telecom module. It's a separate module for folks responsible for telecom and voice quality. We have a separate security module. I'll breeze through that real quick. And also we have a work-at-home troubleshooting solution. One of the things Tom said is, we're applicable to small and medium-sized businesses, but also actually large businesses as well. So we have some very large customers that use this because of the automation of troubleshooting is key to having those large organizations operate. So let's take a look back at really what existing monitoring systems look at. So the average monitoring system, you're going to have to set up a master collector. You're going to have to set up and license and support a database. You have to go set up a couple of remote collectors because they're just not built to scale that well. Then you go out and configure it to monitor your devices. Typically, this is a manual process where you're going out to say, hey, here's all of these devices that need to be monitored. If you miss anything, then oops. At this point, you say, I want more information. I want to know what's going on with my internet connections, my WAN connections, my trunk ports. And so you go out and spend the effort to configure monitoring specific interfaces in the environment. Well, at this point, you've run out of time. You don't have another 6 weeks of time to dedicate to this project, and you've run out of licenses. So this is as far as most people get. Now, the problem with this visibility is that if somebody says, hey, I had a network problem, you go check your monitoring solution, and your monitoring solution says, hey, everything's fine, everything's great. What that is it's a disconnect between the reality of what's happening on the network and what your monitoring system is aware of. That just means that you're left having to log into switches, log into routers, checking interfaces, checking error counters, checking configuration, looking for that needle in a haystack as to what caused the problem. Sadly, I think we all know, if you do this exercise when the problem isn't happening, you're not likely to catch it. And you have to tell the user, maybe the next time this happens, we'll get a little bit closer. Well, that leaves you frustrated, them frustrated, everybody frustrated, because it'll probably have to happen again and again and again before anyone gets any closer to solving it. So we looked at this world and said, this day and age needs to come to an end. What we decided to do is build something that does automated root cause troubleshooting. Here's what we do. We deploy on a virtual machine in the environment. You don't have to set up separate servers, separate database servers or anything. We're going to deploy and automatically go out and scan the network and find every switch, router, gateway, and firewall, along with every interface in the infrastructure. You guys are held to be responsible for the entire infrastructure. We figure we're going to give you visibility that matches your responsibility. That way, if anything happens throughout the infrastructure, you know about it. The second thing we recognize, this network equipment that you guys have, incredibly smart. It's all sorts of information trapped up inside of those boxes. So we decided to also go deep. We're going to collect all the performance, all the configuration, 19 different error counters, all the QoS, CDP, LLDP. All of this rich information comes back automatically, no matter what make, model, or manufacturer. What we then do with this information is pretty awesome. We put it through a heuristics engine. The heuristics engine will produce plain English diagnostics of problems that are found. That means within the first hour of deploying our software, we're going to tell you, hey, we found a cabling fault. We found a microburst link flood. We found a QoS misconfiguration, a VLAN tagging fault, even the lowly duplex mismatch that sadly many other products just aren't aware of. What this means is within the first hour of deploying the software, you're able to start proactively fixing the problems because we've automatically queried the information, analyzed it, and said, here's what's broken. Now, the core package includes everything needed to run a perfectly healthy network. We figure we want to help network engineers solve problems, not end up creating this huge line item inventory list of, gee, we need 3 of these and 8 of these. We figure we're going to do all your diagramming, we're going to do your path mapping, your port mapping, server monitoring, cloud service monitoring, inventory, IPAM, NetFlow, and also configuration automation. All of this is part of the core package. No separate upcharge. Now, our first module, though, is focused on telecom. Here's what this brings to the table. So the first thing is call path mapping. If you have a user that said, hey, I had a poor quality call at 2:30 this afternoon, what happened? You put in the 2 IP addresses of the 2 involved endpoints, it's going to path map and show you every link, switch, and router used to connect those 2 across the network. But on top of that, it's going to also show you what happened at each of those points during this path. That way you can say very quickly, oh, the problem that happened at 2:30, your call quality problem, happened because at 2:35 we were dropping packets out of the high priority queue, and 2 minutes later dropping packets due to a bad station cord. You have a root cause resolution now. You can get both of those problems fixed and tell that user this problem won't happen again. It's all about knowing your network. Okay, second thing we include is a license unlimited call simulator. This can simulate voice traffic across the LAN, across the WAN, all the way end to end. So you can find out where do we see latency, jitter, packet loss, out of order packets, or loss of DSCP. So it's also doing some APM. We have full visibility into Cisco QoS queues. So we'll show how the queues are being used and how they're performing. We'll do SIP trunk monitoring and troubleshooting, locate and trigger alerts if phones move in the environment. So this is everything for your on-prem environment for running a perfectly healthy voice and UC environment. Our next module I'm going to quickly touch upon is what we can do for security. We figure since we have so much information on the network, there's some really valuable things we can do for SecOps. First of which is SOAR. If you have a SIM or an IDS that says we found suspicious activity on this IP address, you put that IP address into TotalView, we're going to tell you, first of all, here's the switch interface in VLAN of where it's connected. Here's the manufacturer of the computer, the operating system deployed, who's logged into the computer, what their rights and capabilities are, what's running on that computer, also who it's communicating with and how, and we're going to give you an overall risk profile. To top this off, we allow you to immediately quarantine, because I think if any of you saw all these indications of compromise, you'd be saying, how quickly can I get this off the network? So this rounds out all that information so that you have a single tool instead of using 6 different tools and saying it's 30 minutes worth of effort to research this. This is now down to 30 seconds and 1 tool. We also have policy monitoring. If you have a high security database that should only be accessed by a set number of users, you want to know when inappropriate communication like this occurs. Well, this would trigger a policy violation alert so that you can go in and say, hey, this shouldn't have occurred. Let's go check the ACLs. Who put this permit all in the wrong location? So that way, if something like this happens, you're aware of it. We synchronize with NIST every 24 hours to determine what are the published vulnerabilities on all of these switches, routers, gateways, and firewalls. So you don't have to have a secondary tool doing this that takes days to be able to scan your network. We're going to be able to tell you we know about the vulnerabilities because we have all of that information already. We have a better understanding of your footprint than many other products. If somebody says, hey, we found a new vulnerability for AudioPhone 335s, do we have any of those on the network or did we decommission all of them? Well, very quickly, you're going to be able to say, we have 3 and here's where they are because you know what's installed in your footprint. We have new device detection. If some mystery device pops into your network, Within 5 minutes, we're going to tell you, here's what it is, where it's connected, who it talks to, and what they're doing. Do you want this on your network or not? Lastly, we have geographic risk awareness, rogue device detection, exposure monitoring, and IoT device monitoring. So it really rounds out all of that communication security that tends to be blind from a lot of folks. So our last module is focused on remote worker troubleshooting. So, everyone's sick and tired of hearing the word hybrid at this point, but I think that's just going to be a standard course for many years at this point. We figure helping those users solve problems is the troublesome part. So if you have a CFO working from home, they have a poor quality Zoom team meeting, how do you help them out? Well, the first thing you do is say, let's scope the issue. So when you scope the issue, you start off and say, well, there's the internet part, there is the Zoom team cloud server part, there's the headquarters part, and then there's the user's home office. Inside of the home office, the user has a $29 firewall, we all know the type, an unknown brand of access point, and they have their laptop. Now, tons of problems can happen from a wide variety of locations, ranging from weak wireless signal strength to wireless channel contention in the neighborhood, firewall issues, ISP issues, split tunneling issues. And if you try and help this user out, typically you say, hey, let's set up a meeting. And you find out that 2 days from now is the first time that your schedules coincide to actually get that meeting to happen. And you get to that point and find out that the user can't even get into the meeting because their connection's too poor. Even if they do get into the meeting, they fumble around, pass control to you, and you find out that ping and traceroute are your only troubleshooting solutions. So we looked at this and said, okay, this needs to be automated. What you do is send the user a single agent and say, here, run this. The non-technical user is going to run the agent, and it's going to perform an automated set of tests against all of these different elements according to the user's perspective of the network. Brings the information back, batches it together, sends it back to the TotalView server. At this point, you get an email notification saying the lab results are in, the doctor can now review what's going on. You take a quick look at this and say, well, looks like your laptop is good. Your wireless signal strength is poor. I'm going to suggest you either plug in, or I think one of the problems is we got a lot of channel contention in your neighborhood with channel 3. If you switch to channel 6, it's going to be a lot better. Also, your firewall is adding a continuous 20 milliseconds of latency. If we ship you a new firewall, that's going to solve that problem. You're also only getting 4.2 megs of upload from your ISP, and also they're dropping a bunch of packets on their second hop router. Can I work with you to open a ticket with your ISP to get that problem solved? So you have all of this rich troubleshooting information right in front of you so that within 5 minutes, you can say, here are 3 things you can do to improve your work at home environment.
Okay, so early on, we said, okay, you're going to be giving plain English. Is this what is shown? Like, is this the plain English, or are you saying this is an interpretation of results?
So for this part here, we're not 100% at plain English yet. We have the information back. We have some of it pre-analyzed, but we're working on adding that analysis to make it so that it is plain English. Because I think you see the point, I see the point is we want to get it down to the point where a help desk person can say, here is your problem. You have a bad firewall that's adding latency. You have an ISP that's throttling your connection. These are the things we need to fix. So we're not 100% there, but we're to the point where some of the tier 1, some of the tier 2 folks can get the problem resolved because the information is right in front of them and they never have to schedule a meeting with the user, and it's all automated.
Okay, so this plain English that we're seeing right on this slide, this is future. That's sort of what you're building.
We can get you this information so that a tier 2 engineer can solve this problem and be able to answer this.
Okay.
We're getting close to that tier 1, but we're moving in that direction. The core part of the product, we've had that for well over 10 years. And so that really is, you have a cabling fault, you have a VLAN tagging fault. So as we add more heuristics to each part, we're getting there. And so you can see how we figured, hey, build this first, get the information. That's the first thing. The second thing is make it easy.
Nifty. All right, cool.
Okay. Other things we can do with this is you can have the user run the client at their house and walk around with their laptop and do a wireless signal strength mapping exercise of their house. So as they start this up second by second, it's going to show the RSSI signal strength. And so this is an example here. I started this in my kitchen, and it was kind of yellow, really not all that good. But as I walked into the living room, it got to be this nice bright green color. And it's like, oh, that's a good place for this. As I walked out the back door into my yard, it quickly dropped away yellow, red, and then black, as I can't do meetings from a lounge chair in my backyard. So a user can self-determine where is their signal strength good versus bad. And they don't have to be a super techie. They just have to be able to look at the color and say, gee, my living room is where I should be doing meetings from.
So when they're going through and doing this, are they seeing those results as they're watching
Live.
And then is there a way, and I guess maybe this is kind of going back to the previous thing, but can they put like a note in there? Like this was the living room, this was the backyard. So that way if they send this and they walk around their house, they get this and they go back to the service desk and they're like, hey, what happens here?
So Tom, this is why I love this. That is a fantastic idea. I'm going to add that to the next version because effectively you're right. Adding those notes makes it so that you have your own documented environment.
Right. I mean, I'm looking at this as you're talking through. I'm like, it'd be really nice if you could just, that yellow, that was the living room.
Mm-hmm.
This is the kitchen. All of a sudden.
This is for the kitchen on 2.5 gigahertz when I'm microwaving a burrito.
Yep.
That was actually a test case, but I'll show you that later.
Quick question for you on the software agent. I see single executable. Is that Windows only or Mac OS?
Right now, Windows only. We do have WebRTC to support Mac OS and phones. So if you have a browser that supports that, it can do a subset of these tests to be able to say, here's what the browser is able to see as far as visibility. Okay. I know there's a lot of other DEM solutions that are out there that just run through the browser. And it's like, yeah, it has all those browser limitations. We figure, okay, we're using WebRTC to do the same thing. But because we have a Windows agent, we're going far deeper. So in one sense, you'll have both. It's just on the Mac OS side and the browser side, there's a more limited subset of tests that you have.
These agents, these are basically like a run once. It's not actually installing.
Nothing to install. Single executable. You can and one thing is, if you don't have local admin rights, it'll still run. If you do have local admin rights, then I think there's 2 tests additionally you can do if you have those rights. So you're not hamstrung by saying, gee, we can't see anything because we don't have rights.
So if this might get into that feature area. So if I've got a help desk engineer, they open a ticket, they want to send this out. Is there anything in that installer that would potentially tie back to a ticket? Like, is there an ID?
No, it'll send it back to the TotalView server on the remote view tab so that you can find that user and say, here's the user, here's the tests that were done. I can get into that when I get to the demo section. But let me see. Actually, no, there's no way to add a note. Okay, that's another feature. I'm gonna have to start paying you. So
He accepts T-shirts this week.
hey, have you checked your bag? You got more than a T-shirt.
That was before the ideas.
That was before the ideas, yeah. So the fact that we have the ability to solve network problems deeper and broader than many other products and have more analytics, more data brought back means people are going to be able to solve problems faster at a lower level in the organization. That just means that you don't need to have as many CCIEs on the team. I know one of the big problems with a lot of businesses these days is hiring people. You might have 6 open headcount in a large network team and say, gee, we just can't backfill these positions yet because we can't hire the people to do this. And you need to backfill with tools. Because this has so much automation built into it, you're going to be able to troubleshoot problems before users actually have the issues. So I know we've kind of semi-opened this up to questions already. So if we want to, I guess, open the whole floor up.
Yeah, you mentioned quarantine earlier for some of the hosts. Is that automated? You get an option to do that? Is it just pushing an ACL out?
So it won't quarantine that way. It's actually going to take that port and lop it off the network.
So no chance of remediation of that host without a physical visit then and plugging it into, it doesn't put it in a remediation VLAN where it can still access the
right. So it's going to shut it down. It's going to add notes to that account. And at that point, you can go back and say, okay, we're ready to put this in a different VLAN, bring the port back online, and then start analyzing. So that would be the process. The first thing is get it to stop talking to anyone. And so we figure just downing that port is the simplest way to get that off the network. There is protection built in so that you can't accidentally down an infrastructure port. That's one of the things we looked at and said, you know, this is just thoughtful engineering of how to design this, is that you can down a port that has a user end station or user workstation or a single device connected, but you can't down an infrastructure port because you just lop your network in half. And that would be very dangerous for anyone to have their hands on.
Are you primarily relying on SNMP to get all this data, or are you relying
So we use
on
a variety of different mechanisms. So SNMP is one of the primary mechanisms, but we're also collecting flows and correlating with that. We're collecting syslog information as well. And then we do have Windows Server monitoring, so we can end up getting WMI information, so you don't have to put agents out all over the place. And one of the things I don't think I mentioned is that this is rapidly deployed. One of my frustrations, again, as I started this discussion, was the average network monitoring software package might take months to properly tune to get the information you want. This is going to be deployed in an hour. If you have the SNMP credentials, if you have the subnets that you want to monitor, within 1 hour, we're going to be telling you things that are broken about your network that you've never known before.
You mentioned policy monitoring. Is that for firewall policies or for ACLs or both?
Kind of both. What it's doing is it's collecting all of the net flow information from across the infrastructure and finding out who's talking to who, and then does this match up with the defined communications policies that you've put into TotalView. So it's going to be watching those policies to say, hey, this communication should not occur. Go check your ACL because it's probably broken. And then licensing.
Yeah.
So licensing is based upon the size of the network. What we do is we count up all of the interfaces, all the network interfaces. So effectively all of your Ethernet ports on all your devices, put that into a pricing bucket. And then based upon the tier that it is, it can be very inexpensive for small businesses, still reasonably priced for large businesses.
So earlier when you were kind of talking about going through the deployment and running out of licenses, you have a hard cap on that license, or is there kind of a little bit of wiggle room where I just added a 48 port switch, but I only have 28 licenses left?
So yes, there is a hard cap, but usually the way we sell it is we say, let's just get this priced right so that effectively if you say, gee, I've got 4,000 interfaces on my network, it's like, okay, the price break at 5,000 makes it cheaper. Let's just get you the 5,000. So most people end up with quite a bit of a float, so they can just add devices as they need, and they never run into that hard cap because we're not charging a fortune per interface. I think what most folks will find is a pricing tool on our website. We're actually far less expensive as a network monitoring solution than a lot of other companies that are out there that have folks that'll buy you steak dinners and take you golfing on Top Golf.
So with the licensing questions are always fun. You got a 48 port switch, but only 8 ports are in use. Are you licensing all 48 or just what's active?
So you can choose to do either. We recommend monitor the whole switch because I think we've all encountered the situation where somebody says, hey, I found this old 20-year-old HP JetDirect printer and I plugged it in and now it's spitting out Apple Talk broadcasts. You want to know, hey, that port came alive and we're seeing a whole bunch of unknown protocols from that so that you can say, hey, let's get out there and find out what that is. So monitoring all the ports has incredible benefit. If an organization says, hey, we know that ports 20 through 48 are never going to be used because they're down. This is a banking environment. Nobody can get access to the closet. You don't have to pay for those. So you can remove those from monitoring. So you're not required to monitor everything. It's just you have to be careful. If you're going to up the port, you realize that's out of your visibility if it's not being monitored.
So maybe there's a compromise here, which would be to look at having ports that are down, not counting towards your license count, or down for a period of time. And then if they come up, that automatically adds one to your license port count. Because to your point, I mean, I when I tried this before, I did spend time going through, like you say, removing interfaces so that I wasn't swamping a license count. And you're absolutely right. The moment one of those gets turned up, I've just added technical debt because I have to go back and add that thing back into monitoring. Because
and nobody has time for that.
Right. And that just made me wonder if there's a way to kind of make that more dynamic to say, okay, look, the ports are down and or they've been down for a week. I think we can consider that a non-port and remove that from the license count.
So yes, that can be done. There's a script that we can add to it that will go through and say any ports that are down, remove those from monitoring, and thus remove that from license count. You just have to be aware that when that script runs, if that port is down, it's not going to be monitored, so that when it comes back up, we don't know, because, and so having that script run on a nightly basis is really the trick.
Yeah, and so I'm kind of saying run the script, but keep it monitoring.
Could
You know, keep monitoring a dead port, but don't, once it comes up, if there's license count available, send the alert, reveal the data if that's what you want to do. I'm just trying to avoid the turning off the monitoring bit.
Well, so we're trying to reduce the administrative effort. So effectively monitoring all the ports, we've priced it really low. That means you can just say, oh, compared to any other product, yeah, let's get full total network visibility, which that's the game. You don't have to worry about it. That way you're not, because fussing with licenses, sorry, Cisco, you're fussing with licenses is something that folks just don't have time for. It's like in the average sysadmin, you figure most of their time is spent troubleshooting. Sadly, that licensing is starting to become 2, 5, 10% of their job, and it's like, oh my God, that didn't exist before. So we want to have this so that licensing is a non-issue.
That sounds low.
5% is low.
That sounds low. Licensing is.
Yeah, so we make the licensing really easy, and it is reasonably priced.
With the licensing then, so you mentioned there's a script. I would presume then you could basically run that essentially in reverse. So using your example of a bank with like these first 20 ports are in use. Hey, we're adding, a new camera system. We need to add 5 ports. Is there just a, programmatically, ports 21 through 25, just bring those up? So, I mean, it's still admin effort, but you could, if you were trying to really be conscious of that licensing, there's ways that you could script it out.
So here's another thing is, I looked at a lot of the monitoring software out there and they hide everything inside of a database. And I don't know a single network guy that even likes talking to a DBA. I hope you guys aren't DBAs.
we like to
okay, Tom, you can get out of here.
we like to pick on 2 people, DBAs and DNS administrators. Either one.
So we looked at this and said, okay, we're going to put a minimal subset of data in the database and use a very high performance, non-managed SQLite. We're using SQLite as our database so that you don't have to worry about licensing. You don't have to worry about performance. Everything is compiled directly into the solution. So it's a set it and forget it type of database. But all of our configuration option, it's all stored in text files back on the server. So any of you guys familiar with how Linux does everything, you can go through and say, hey, I want to change these files. I want to have these modifications done, search and replaces. It's very quick. So if you want to do a large scale, like change every community string in your environment, one search and replace, and you're done. So by having the stuff not hidden in the database just means that you're going to be able to function a lot faster and manage the tool. This is also why for very large organizations, we can deploy very rapidly, because we have that ability to say, let's script some of this stuff, and it's all right here for anyone to access. And most network folks perfectly happy working with text files until you guys learn how to speak SQL, which I just don't think you want to. So yeah, you can do automations with license management, that sort of stuff.
Like I saw the next one then. So really you're looking at kind of the visibility side. This isn't a kind of a config management tool. You're not really pushing changes back to the device.
We also have configuration management. So yes, we cover that base. It's part of the core. So we don't charge for that. We figured this is just what you need to run a network. So that core NetOps has everything you need to run a network. So configuration management will back up your configs Friday night at 8 p.m. for every device. We will also notice that somebody put a new static route on this router. The moment that config goes in, we're going to go make a backup of it. We're going to do a diff against the previous backup and then send the team and say, he just put a new static route in on the core router, so that everyone knows, oh, this just broke something. Here's who to point the finger at, and here's what needs to be backed out. Third thing is large scale configuration changes. So if you want to put, let's say 100 lines of ACL out on all of the Nexus switches in the Chicago data center, that's one click.
There's a lot under the hood here, like a lot. Can you and it doesn't have to be an in-depth conversation, but peel back to version 1.0 and whatever version we're at today. Like, what was the path that led to, what was the path to your path to really put all of this under one platform?
It was just a personal frustration. So I worked as a network engineer, network manager, network director, and it was a personal frustration with the amount of time spent troubleshooting. And I looked and said, this is just growing and growing and growing. And I figured networks are getting more complex. There's more new technologies coming down the pike. And also, there's more difficulty in hiring experts to be able to do this. You can't say, hey, I want to hire 3 CCIEs for my mid-tier company. They're just going to say there's no budget for that. Why don't you hire a couple more junior people, and that's what you're going to get. So how do you get more junior people to operate at a more senior level is you have automation. And so we initially started saying, let's get SNMP and get all of the rich data off these devices. Let's now, once we finish getting it, let's start analyzing this. And we found, oh, it's easy to determine what a duplex mismatch looks like. Okay, there's a plain English answer. It's easy to determine what a cabling fault looks like. That's what this is. It's easy to end up determining a VLAN tagging fault or an MTU misconfiguration. So specifying those, hey, here's where the problem is, here's what the problem is in a plain enough language so that a junior level person can say, oh, I will go out and check the patch cord. Cat 3? What's a Cat 3 patch cord? When's the last time you guys have ever looked at a jacket? Nobody looks at cable jackets. So there could be.
It's been a while, but I have.
But you'll find it's like, this is a Cat 3. Oh my God, this should have been thrown away a decade ago. But it's this sort of stuff that trips up network folks everywhere. And if they could be told, go out and look at that cable jacket, you're going to find something suspicious. So that was really the impetus to get this to work. And what we found is early on, we made our hay with VoIP. And VoIP, root cause troubleshooting for voice quality, packet loss was rampant really 10 years ago. And that packet loss made it so that you pick up your VoIP handset and say, yeah, how you, what, can you say it again? What? Okay, now it's clear, I can talk to you. It's like all that packet loss ended up creating problems that we were uniquely positioned to solve. And we figured, let's master that domain. And we did. We became the #1 solution for solving voice quality problems in networks. And really what we found is as our feature set expanded, we figured, okay, let's get into the general network monitoring marketplace because we're solving problems better than a lot of the other players that are out there because we have more breadth, more depth, and more analytics.
So I'm trying to land this in terms of who your market is or what the size of the organization is that you try to fit this in. So let's say I'm large enough and I do have a couple of CCIEs and I've got a route team. Is this going after the groups that are that large, or are you just trying to fill in like that smaller than giant enterprise space to give the more medium tier that level?
We'll sell 1,000 interfaces to a company that says, hey, we've got 200 employees. We got 1,000 interfaces in our network, and we've got one IT person, our first IT hire. And they're saying, I've got to use something to help solve problems because there's only one of me. I'm a jack of all trades, and I don't have all the knowledge. I don't have that CCIE smarts yet. And so having this come in and solve problems for those folks is a lot better than a basic monitoring tool that pings things and tells them some utilization graphs. So that's a perfect application. We're going to go all the way to the other side and say, you have your large team. You've got 3 CCIEs. And those 3 CCIEs are saying, I don't want to do tickets anymore. I want to do strategic level things. And the manager as well. They don't want them doing tickets. They want them doing strategic level things that actually move the business. How do you do that? You have that layer 2 and layer 1 folks equipped with a tool like this that will say, any duplex mismatch gets automatically solved by layer 1. Cabling faults, layer 1 or tier 1. So all of those problems get solved by lower layers in the organization, and the whole team works more efficiently. So we have examples of businesses on both sides, the itty bitty business where there's not enough smarts, and the huge organizations that say, we need to push those tickets down further. And the frustration I found is a lot of the big tools that are out there, a lot of the big companies that do those big monitoring systems, they don't have the analytics built in. So that means that you have to go out and say, oh, go pull this OID. Oh, it's not supported on that box. Go pull the other one. We've automated all that. So all of that information comes back to us. You don't have to program it, and we're analyzing it at the same time. Thus, you have resolution. That's really a figure at the end of the day. What you want is resolution as fast as possible, as low in the organization as possible. So does that answer your question of how we play into both worlds?
Yeah, it does. It definitely clears it up.
So with the kind of the analytics side, presuming you're taking, these are the criteria, this is what we're seeing based on this, we're making a presumption that it's a duplex issue. Do you have a kind of a rough number of how many of those kind of plain language we get 10, 20, 50, 1,000? How many answers do you have today?
So our heuristics engine has about 140 different conclusions that it can come up with. And we figure if these 140 conclusions are automated, that just means that that junior level person is solving that problem. And each release, we come up with some more conclusions. So, we'll sit around and I'll admit there's alcohol involved, but we end up coming up with, hey, what if we could solve this problem? Okay, what information would we need to solve this problem? Okay, how do we automate that collection? How do we automate the interpretation and then come up with that new conclusion?
Do you have this, maybe wishful thinking, but do you have any actual kind of statistics on how well that's worked from an organization? Like we went from this many tiers going to the architect or the senior engineer to this many tickets are actually getting escalated and this many are getting that first call resolution.
So in one sense, I'll say our company is engineering heavy and marketing light, meaning that we haven't done that marketing analysis of saying, oh, here's your ROI, based upon this size of company and these sort of stats. And so we haven't done that yet. Probably ought to do that, but not yet. I think the proof is in the pudding. Usually most people, they'll deploy and they'll say, oh, usually in the first proof of concept, they'll stop and say, hold on, got to take care of something embarrassing because we found something on their network that they're like, has been plaguing them for a long period of time. So the proof of concept ends up proving a point.
You were talking about agents on Windows clients. Do you have the ability to do any type of packet capture or anything like that to then send on? And
so that's the one thing we don't do yet is we're doing all the NetFlow, all the SNMP, traps, syslog, WMI, but we're not capturing packets yet. In one sense, I kind of look at the world and say, there's a lot of really good solutions out there to do packet capture. Ranging from, the free Wireshark with its analytics, it has some fantastic analytics for voice, SIP ladders, all of that sort of stuff. And then you have paid for solutions that have all sorts of features. And I'm kind of like, you know what? I don't think we're going to be able to master that domain because there's a lot of other companies in that area. But the domain that we can master far better than those other solutions is the SNMP, the analytics, and the troubleshooting with that information that's on the devices. So we kind of don't want to enter an area if we can't master it. And that, in one sense, packet capture is it's valuable in certain cases. In one sense, though, I'll say, I think some people tend to overvalue a packet capture. And what I mean by that is, let's say you have a call quality problem and say, yeah, I've got cutouts, I can barely hear audio problems. Packet captures can't solve that problem because if you have the packet capture done in the wrong location, it's not going to see any missing packets because the missing packets are downstream from where the capture was done. So you're constantly moving the tap or the span port to different locations. The other problem is, even if you do say, hey, we're seeing missing packets, great. All you've done is confirm a problem. You're not going to find it that way. You still have to go check to see where are those packets being dropped. And that's going to be on one of the switches. And it's going to be an error counter on a switch saying, hey, we're seeing MTU problems on this port, or we're seeing QoS problems, or we're seeing FCS errors. And so those error counters are the trick for finding out where those packets are actually being dropped or even buffered. So we can find latency problems better than anyone because we know where there's buffering going on throughout the infrastructure.
yeah, I was thinking the packet capture more to help with some application troubleshooting if you were, looking to extend the problem or your solution to those types of problems, or, it sounds like you're sticking to strictly network related problems.
So yeah, actually excellent way of framing that is, so we started figuring, let's get all layer 1, layer 2, layer 3, and some of the layer 4 problems solved with QoS. So we figure if we solve everything from that layer, from 1 through 4, then at that point, the network engineer's job is going to be easy because they're going to know everything about their network. Application layer, usually you're right. You're using a packet capture to go top down to say, okay, do we have the right protocol? Are we seeing, how long was this file download taking? And so top down is really, that's where packet capture is going to shine. So having us go up further through, session layer and go up, that's probably our direction next. But I don't think we're going to come in conflict with a packet capture that starts from the top down.
Right. Well, in most of my most of my customers, the network's guilty until proven innocent. So it's usually a network engineer looking at a packet capture problem to point that, hey, you need to prove that it's an application problem, and that's one of the tools to do that. Simply saying that your round trip time and your latency and all that other stuff is fixed, it's a solved problem or whatever, still doesn't usually provide innocence to the network team.
What I'd probably do is I'd actually, before even doing packet capture, is I do APM. So you do some application performance monitoring. We do have a call simulator that will find out, do you have latency, jitter, packet loss, out of order problems, loss of DSCP, and it can be able to tell you, hey, 3 hops in, that's where you're dropping your packets, or that's where your latency is occurring, or that's where your DSCP tag is being stripped. So it'll be able to show stability across that network so that you can say the network is perfectly stable. And at that point, you rule out layers 1 through 4 and say, this is limited to now to, it could be a server problem, it could be a client problem. And that way you can rule out the network.
Yeah, that makes sense. It's just in my experience, most application people need to see that, oh, you made the wrong call to a database. And in my experience, that's still the network engineer pointing out here, see, here's the error.
Yeah.
So no, but that's fine. If you're not doing packet capture, that's cool. It was just, I'm just wondering if that was a feature.
One of the simplest things I found is I worked for a company that did hosting, and the simplest way of troubleshooting that is, does it run smoothly on the server? If it's terrible on the server, it's like, it's not going to get any better over the network, but that rules out the network as the source of the problem.
APIs, integrations with other tools, platforms, is that?
So APIs were fully RESTful JSON on the front end. So it's a very snappy front end user interface. We have our SQLite API, so you can get at our data in the database. All of our config files are all text files again. So that's just a direct manipulation. Integrations to others. So we have an integration to NetAlly. You guys familiar with NetAlly's tool sets? They're ether scopes.
Oh yeah.
Okay, they're fantastic stuff, really good stuff. So we figured we'd start a partnership with them and say, okay, if you have a NetAlly box and you place it under somebody's desk and start doing some tests on there, that's fantastic. It's going to spit its data up to their Link Live portal. We integrate with that Link Live portal to be able to show, here's where that analyzer is. It's on port 2 of the finance switch. So if you lose it and you're wondering, where did it go? Oh, that's where it is. But we'll also be able to link into those tests so that you have a unified experience of finding out what's wrong with the network and what are the test results coming off their units.
This is more of a NetAlly question than it is a PathSolutions question. But is that something proprietary between you guys, or do they have like an API?
They have an API, and we're, as far as I'm aware, we're the first company to build into that API to get this test data shared.
I've been using NetAlly before it was NetAlly.
The Fluke days?
After it was, even back to Fluke, but even that in-between period. And I've not seen anyone integrate with their data before. So hearing...
I'll show it.
That would be cool. It's an awesome platform. The hardware testers are what the old Flukes used to be, and now they're green and they own them. But yeah, that's really cool. I'd love to see that.
Okay, cool.